Hi, this is Shankar, and in this video, we are going to discuss about the pin diagram of 8051 microcontroller. The 8051 microcontroller is an 8-bit processor. In this 8051 microcontroller can work only 8 bits of data at a time. The 80 microcontroller can have only 40 pins and it's specially dedicated for various functions such as input, output, read, write, transferring address, data, and interrupts. Some companies are providing 20 pins version of 8051 microcontroller with reduced number of IO ports also. But in this video, we are going to discuss about only 8051 microcontroller. This 8051 microcontroller with 40 pins can have four 8-bit IO ports, namely P0, P1, P2, and P3. And each ports can uses 8 pins. So totally 32 pins are reserved for IO ports in 8051 microcontroller out of 40 pins. Remaining 8 pins are uses for VCC, power supply, ground, XTAL1, XTAL2, reset, PS, EN, ALE, and EA. In this out of 40 pins, already we discussed that four 8-bit IO ports are there. So let us see how to remember these four ports. Then it is very easy to complete 32 pins out of 40. So from 1 to 8 pins, it is reserved for port 1, namely P1.0, P1.1, P1.2, P1.3, P1.4, P1.5, P1.6, P1.7, which means that port 1 dot zeroth pin, port 1 dot first pin, like that. So totally first 8 pins are reserved. And next from pin number 10 to 17, from pin number 10 to 17 is reserved for port 3, which helps you to perform multifunctional operation. And next from 21 to 28 is reserved for port 2, which helps you to transfer only address. And from 32 to 39 is reserved for port 0. In this case, you just give the reverse order. That is means 7, 6, 5, 4, 3, 2, 1. Because the previous P1, P3, P2 are named as per the order 0 to 7, 0 to 7, 0 to 7. Only the V0 will be in the reverse order from 32 to 39. The port number will be 7 to 0. This port 0 helps you to transfer address or data. And P2 is helps you only to transfer address. And P3 is multifunctional. P1 is transferring data. So let us see one by one. So initially you just fill 20 and 40 because it is well known. 20th pin is helps you to connect the ground and 40th pin is connect to power supply. And first fill that 8 pins, then it is very easy to fill the remaining things. So before 20, we have 18 and 19. The 18 is XTAL2 and 19 is XTAL1. So let us see what is XTALs. The 8051 has on-chip oscillator, but it requires external clock to run it. A quartz crystal oscillator is connected to inputs XTAL1 and XTAL2, respectively the pin numbers 19 and 18. If you are using a frequency source other than the crystal oscillator, such as TTL oscillator, it will be connected to XTAL1, and in this case, the XTAL2 is left unconnected. Next, reset. The reset pin will be there in ninth pin of 8051 microcontroller. Reset pin is an input and is active always high. Normally, it is low. Upon applying high pulse to this pin, the microcontroller will reset and terminate all activities. This is often referred to as a power on reset. Activating a power on reset will cause all values in the register to be lost. And next, pin number 29, that is PSEN, which means that program store enable. It is an output pin. This pin is connected to OE pin of the external memory. For external code memory, the PSEN value is 0. For external data memory, the PSEN value is 1. And next, pin number 30, it is ALE. This ALE pin is used for demultiplexing the address and data. Next, 31, pin number 31. EA, in the sense external access, it is an input pin and it must be connected to VCC or ground. The family of 8051 all come with on-chip ROM to store programs and also have an external code and data memory. Normally, EA pin is connected to VCC. If EA pin is if EA pin is connected to ground, it indicates that the code or data is stored externally. So far, we had discussed about the 8 pins, right? So once again, I recall the pin numbers. Ground is 20, VCC is 40. And next 18 and 19 is XTAL1, XTAL2. And next the pin number 9 is reset. And next 29 is PSEN, 30 is ALE, and 31 is EA. So out of 40, we have filled 8 pins. The remaining 32 pins with the port, we will discuss one by one. So first one is port 0. Port 0 is connected from the pin numbers 32 to 39. Port 0 is also designated as AD0 to AD7 because this port 0 can able to transfer either data or address. When connecting an 8051 to an external memory, port 0 provides both address and data. The 8051 multiplexes addresses and data through port 0 to save the pins. In this case, ALG is indicates the port has address or data. If the ALG has the value 0, it provides data. If the ALG has 1, then it provides the address. Next, port 1. Port 1 is connected with the 1 to 8 pins of 8051 microcontroller. These 8051 based systems with no external memory connection, port 1 as well as port 2, both are provides a simple IO operation. So in this case, the port 1 will helps you to perform IO operation and it can able to transfer data only. And next, port 2. In 8051 based systems with external memory connection, port 2 must be used along with the port 0 to provide 16-bit address for the external memory. In this case, port 0 provides a lower 8-bit via A0 to A7. And next, port 2 is used for the upper 8 bits of address from the 16-bit address designated as A8 to A15, and it cannot be used for IO in this case. And this port 2 uses 21 to 28 pins of 8051 microcontroller. And next, port 3. Port 3 helps you to perform multifunctional operation. In this case, each pin can perform various operations. In this case, the pin number 10 is perform a reception operation and 11 is transmission operation. Both 10 and 11 is helps you to perform serial communications. And next, for external interrupts, pin number 12 and 13 is used. And for timers, pin number 14 and 15 is used. For read write, 16 and 17 is used. So from the 8051 microcontroller, pin number 10 to 17 are helps you to apply the port number 3. Thank you all for watching this video lecture series. Thank you.